In late 2023, more than 20 billion kilometers from home, humanity's most distant spacecraft suddenly started talking nonsense.
Voyager 1, the first machine to leave the solar system, was sending only gibberish, a stream of ones and zeros that no longer meant anything. For 5 long months, engineers could see the probe was alive, but blind to what it was actually sensing at the edge of interstellar space. Each command they sent took 22.5 hours to arrive, and another 22.5 for any answer to come back. Every attempt to fix it was a shot in the dark, knowing that a mistake might silence the spacecraft forever.
Eventually, the team traced the problem to a tiny chunk of corrupted memory in one of Voyager's ancient onboard computers.
They rewrote the software in slow motion, relocating code to undamaged memory banks on a probe built before many of them were born. Then they waited, staring at a timer, hoping that somewhere beyond the solar system a 47-year-old computer would understand.
Any people? In Voyager 2024. Finally, one questions were finally added again.
The story begins in 1977, when 2 small spacecraft left Earth on a mission that was supposed to last just 5 years.
Voyagers 1 and 2 were sent on a grand tour of the outer planets, using rare planetary alignments to slingshot from world to world.
They gave us our first close-ups of Jupiter's storms and Io's active volcanoes, turning blurry dots into real places.
They swept past Saturn's rings, discovering faint new moons and a delicate ring system more intricate than anyone imagined.
Voyager 2 went on to visit Uranus and Neptune, still the only spacecraft ever to see those ice giants up close.
Each Voyager carries a golden record, a time capsule with sounds and images of Earth, meant for anyone who might one day find them.
But the most shocking discoveries the Voyagers made were not at Jupiter or Saturn, but far beyond the planets, where the sun's influence fades. Our solar system is wrapped in a huge bubble of charged particles blown out by the sun, called the heliosphere.
Inside, the solar wind races outward faster than the speed of sound in that plasma.
The termination shock is where the supersonic solar wind is forced to slow down abruptly, like air slamming into the front of a speeding car.
Beyond that lies the heliosheath, a chaotic region of slowed, heated solar wind mixed with interstellar particles and twisted magnetic fields. At the very edge is the heliopause, the shifting boundary where the sun's wind can no longer push back the thin gas between the stars.
After its last planetary flyby, Voyager 1 headed northward out of the solar system, toward that invisible boundary.
In December 2004, at about 94 times the Earth-Sun distance, Voyager 1 crossed the termination shock and entered the heliosheath.
Instead of matching simple models, the shock behaved in unexpected ways, and energetic particles kept tensifying downstream.
The heliosheath turned out to be messy and turbulent, more like cosmic whitewater than a quiet outer shell.
Then, on a day in August 2012, Voyager 1 crossed a final, sharper boundary. Solar particles dropped away, while galactic cosmic rays from outside the solar system surged, a key sign that it had left the sun's protective bubble.
Yet the direction of the magnetic field barely changed, defying expectations that it would rotate dramatically beyond the heliopause.
That subtle twist forced researchers to rethink how the sun's magnetic field blends into the interstellar field around us.
Measurements of plasma density confirmed it. Outside the helios, the surrounding gas is 20 to 50 times.
Today, Voyager 1 is sailing through the very local interstellar medium, sampling the space between stars for the first time in history.
Its plasma wave instrument hears faint, constant tones from interstellar plasma, letting scientists measure how dense the space around it really is.
Those tones reveal that interstellar space smooth.
Voyager 2 followed a different path, crossing the termination shock in 2007 and the helio in 2008.
The two probes crossed the heliopause at similar distances, but very different angles.
Voyager 2 found a thin magnetic barrier, where compressed solar magnetic fields strongly influence how...
Together, the Voyagers showed that our heliosphere is not a perfect sphere, but a distorted bubble shaped by interstellar pressure and magnetic fields.
The edge of the solar system turned out to be stranger and more dynamic than the simple textbook art many of us grew up with.
The heliopause breathes, moving inward and outward as the solar cycle waxes and wanes, and the Voyagers have...
Outside that boundary, the Voyagers measure galactic cosmic rays with far less solar interference. Those measurements matter for future interstellar travelers, because they tell us how harsh space really is.
For Universe Unlocked, the Voyagers are not just relics. They are our only active scouts outside the sun's protective bubble. Out there, Voyager 1 runs on fading nuclear power, so weak that every watt must be negotiated. NASA has begun shutting down instruments to keep the most crucial ones alive into the 2030s, trading data for time.
Each Voyager now operates only a handful of instruments, focused on magnetic fields.
The recent mysterious signal,
Once engineers moved critical code into healthy memory and rebooted parts of the system, the gibberish turned back into real numbers about the spacecraft's health. Only a few % of the memory was damaged, but that was enough to break the translation between what Voyager saw and what we received.
When readable engineering data finally came back in April 2024, it meant the most distant machine ever built by humans was fully under our care again.
That signal did not contain a cosmic revelation. It contained something almost as precious for the team.
Step by step, they are working to restore full science data, so Voyager can keep mapping interstellar plasma around the heliosphere.
With every bit of data, Voyager sketches a more detailed picture of the medium our solar system is moving through.
The heliosphere is not stationary. It plows through the galaxy, and the Voyagers are giving us a from launch to grand to interstellar mission.
The real shocks at the edge of the solar system are these. The heliosphere is asymmetric, the boundary is thin, and
magnetic reconnection at the heliopause may funnel particles and energy across the boundary, turning it into an active interface rather than a simple wall.
The Voyagers saw solar wind flow drop to nearly zero, while cosmic rays jumped, showing where...
Their data also reminds us that our planet lives inside a shield, one we did not even know the shape of a few decades ago.
You may never stand at the edge of the solar system, but through Voyager signals and stories, you can understand what it is like out there.
That is what Universe Unlocked is for. Taking the raw data from missions like Voyager and translating it into a story that finally makes sense.
From heliosphere edges to alien megastructures, from real engineering fixes to wild what-if questions, Voyager 2, with its working plasma instrument, confirmed the density jump and helped show how the heliopause behaves in a different direction. Comparing the two crossings showed both similarities and surprises, proving that the boundary is not uniform, but patchy and evolving.
Voyager 1's long baseline through interstellar space has revealed density fluctuations on scales from a fraction.
In a few hundred years, the probes will reach the Oort cloud, and long after their power dies,
Eventually, they will become silent, unpowered relics, tiny pieces of our story drifting between the stars.
The golden records will still be there, carrying music, greetings, and images from a civilization that once... They were not meant to be practical. They were a statement that we existed.
Down here, giant radio antennas still listen for faint whispers from Voyagers, signals so weak they could be mistaken for noise.
The fact that we can hear them at all, from beyond the heliosphere, is a triumph of precise engineering and patient listening.
Before Voyagers, our ideas about the solar system's boundary were mostly theory and computer models. After Voyagers, they are data-driven.
They pin down where the heliopause actually is, how cosmic rays leak in, and how the sun's bubble fits into the larger galaxy around it.
The edge of the solar system is not an ending. It is a transition zone into a new kind of space with its own rules. Other missions study the heliosphere from inside, but only Voyagers give us in situ measurements from outside looking back in.
Vivas. Geshios 2020 was a reminder that this mission is fragile, but it also showed how far we will go.
At Universe Unlocked, we see Voyagers as the perfect example of what happens when curiosity, engineering, and patience are all aimed at the unknown.
If you enjoy journeys like this one, there are many more edges to explore. Exoplanet atmospheres.
Somewhere on one arm of this galaxy, two tiny probes are still sending back clues about a border we only just learned to see.
The truth from Voyager is shocking enough without exaggeration, and it is our job to tell that truth clearly.
In the end, the most moving discovery was not a new plasma boundary, but the realization that a probe from the
Two generations of problem solvers separated by half a century now share the same spacecraft, whispering to it across the dark.
Somewhere, a child hearing about Voyager tonight will grow up to work on the missions that go even farther.
If you want to follow those journeys from the beginning, this is the place to do it.
Subscribe to Universe Unlocked to keep up with the real science behind the most dramatic stories in space.
You have just seen what the Voyagers really discovered at the edge of the solar system, and why it matters for our future beyond it.
Out there, beyond the sun's wind, Voyager keeps going, a small